This video is going to show how to create a behavioral diode model in PSpice Designer. Determining and selecting the right diode for your design is essential. Simulation can be used to help determine the best diode. However, new diodes are frequently introduced into the market without SPICE models readily available. New in PSpice 24.1 is the ability to create behavioral diode models quickly and efficiently to determine the optimal diode properties for circuit functionality. Start by opening the provided design in PSpice Designer 24.1 or later. To place the behavioral diode model, select Place Component from the menu. The Component Explorer tab opens, showing a list of components that can be placed in the schematic canvas. Expand PSpice, Discrete, Diodes, and select General Purpose. The list has been filtered to show general purpose diode models, but is still too long to sort through manually. Let's filter the list further by entering behavioral into the search field. Press Enter to search. The list is filtered to the single entry D behavioral. Select the component to view its properties. Right-click and select Place to attach it to your cursor. In this example, we'll place 4 behavioral diodes to form a full-bridge rectifier circuit. When finished, right-click and select End Mode. To create behavioral diode models, parameters can be edited in the Property Editor tab. Properties can be defined for all 4 diodes simultaneously. To do this, hold Ctrl on the keyboard and click to select the 4 diodes. Right-click one of the diodes and select Edit Properties to open the Property Editor tab. The property table for all 4 diodes is listed. Let's use a datasheet to make these diode properties easier to define. Open the provided MCC datasheet in your preferred PDF viewer. This datasheet lists properties for a set of similar diodes. In this example, we will model the ER2DL. The maximum ratings table shows that this diode has a maximum peak reverse voltage of 200 volts and a maximum average forward current of 2 amps. We'll assign the reverse voltage first. In the Property Editor table, right-click the rev header for VREV and select Edit. Enter -200 for VREV and click OK. Let's assign the current limit next. Right-click the row header for iLimit and select Edit. Enter 2 for the limit and click OK. Back in the datasheet, scroll to the second page to view the electrical characteristics table. According to the table, the diode we want to model has a forward voltage drop of 0.95 volts, a reverse current of 5 microamps, and a reverse recovery time of 35 nanoseconds. In the Property Editor table, voltage drop can be assigned to the V forward property, and reverse current in the breakdown region can be assigned to the Rev iLimit property. We can approximate the current when the diode is reversed bias, but not in breakdown with the R-off property. The datasheet says that the reverse leakage current through the diode is 5 microamps at the rate of reverse voltage, which is 200 volts. By Ohm's law, this gives us an off-state resistance of 40 megaohms. Additional properties can be defined, such as quadratic width, temperature coefficients, and noise parameters. Click Apply and close the Property Editor tab. With the diodes placed and the relevant parameters defined, we are now ready to run the simulation. Select PSpice New Simulation Profile from the menu. In a new simulation window, name the simulation and click Create. If the Simulation Manager Product Choices window opens, select the appropriate license and click OK. The Simulation Settings window opens. Here you can define the type of simulation to run and configure all options for that simulation. Enter 40 milliseconds for the run-to time and 10 microseconds for the maximum step size. Leave the other settings as the defaults and click OK. To plot simulation results, we need to place probes on the schematic to indicate what to plot. Select the Voltage Level Marker button from the toolbar. Click to place a probe on the Vout net, then right-click and select End Mode. Select PSpice Run from the menu to start the simulation. The simulation plot opens in the PSpice AD window. The output voltage rises to 14.14 minus the diode drop and holds above 12 volts with some ripple as expected. Close the PSpice AD window. Now let's create a Zener diode model. Back in Capture, select the Component Explorer tab to reopen the component placement list. Double-click the D behavioral entry to attach another behavioral diode to your cursor. Click to place the model between R1 and ground, then right-click and select End Mode. We need to remove this wire segment between the diode anode and cathode to run the simulation. Select the segment and press Delete on the keyboard. Let's define the diode properties. Right-click the diode and select Edit Properties. Open the other provided datasheet, ds18010.pdf, in your preferred PDF viewer. Scroll to the electrical characteristics table on the second page. For this example, we'll model the NMSZ5231B and read parameters from that row. In the Property Editor tab, define the current limit, breakdown resistance, reverse current limit, off and on state resistance, forward voltage, and reverse Zener voltage. Click Apply and close the Property Editor tab. Back in the schematic canvas, click and drag the probe to move it to the net between R1 and the new Zener diode. This will change the plot to show the voltage at that net. Select PSpice Run from the menu. The simulation plot shows that the voltage at this junction holds at approximately 5.1 volts. Create behavioral diode models with full customization of diode parameters for quick, easy, and efficient diode simulation in PSpice Designer 24.1. For more tutorials, visit us at resources.ema-eda.com, and don't forget to like and subscribe to our YouTube channel.